Hi everyone, this is Dr. Swaminathan SM. Now I am going to take the seventh topic, that is block diagram reduction technique. So first review about the previous class. We discussed about the translational, rotational and mechanical system and introduction, need for the block diagram reduction technique, basic elements of block diagram and block diagram reduction techniques, that is important, 8 formulas, that is 7 rules. And again the activity, following with the activity we'll discuss about the 2 examples and summary. In the introduction, it consists of a single block or combination of blocks that is used to represent the control system in a pictorial form. Input means that is R of S, and output block, that is C of S, transfer function G of S. So G of S equal to output C of S divided by input R of S. The flow of information is unidirectional, and output being equal to input, that is multiplied by the transfer function of the block. The need for the block diagram reduction, it's normally required to reduce the multiple blocks into single block, or convenient understanding it may sometimes require to rearrange the blocks and into the original order. So the calculation of the transfer function is required and it's to be reduced. So here the summing point, that is plus or minus, and G of S is on block, and another that is called takeoff point for the feedback loop H of S. So C of S and R of S is, C of S is the input, R of S is the output. Next, the block diagram, that is basically modeling any simple or complex system. It consists many blocks that is connected together to represent the system to explain how it is functioning. So transfer function means output divided by input, and the condition is, that is initial conditions are 0. So simple system G of S, R of S is the input, C of S is the output. So G of S equal to output divided by input. Complex system means there are so many G and H is included. That is called a complex system. So basic elements you will see, block, that is X of S, Y of S, G of S, that is our system. So Y of S equal to G of S into X of S. Summing point, that is Y is equal to A plus B. And minus means Y is equal to A minus B. These are all the ruling technique. Combining blocks, that is the first rule, combining the blocks in the cascade. So G1, G2, that is a cascade format. Then that equivalent diagram is G1, G2. So first the rule, and second column is original diagram, and the third column is equivalent diagram. Next, two, combining the parallel block. So G1, G2. How can you say it is parallel? The both end is connected with each other. So both are parallel means G1 plus G2, that is equivalent diagram. Moving a branch ahead, that is G1 to another side means 1 by G1, that is G1 into 1 by G1, that the equivalent diagram. Look at this, that is the rule 3. And rule 4, that is moving a branch point before the block. So before means that is G1, G1, that's all. After means 1 by G1, before means G1. So moving the summing point ahead of the block means that is G, that again upper side, that is multiplication x2 into G, that is x1 plus x2 into G. Moving the summing point before the block, that is equal to 1 by G. So just remember, ahead means G and before means 1 by G. And again another rule, that is elimination of feedback loop GH, that means equivalent diagram G divided by 1 plus or minus GH. That is very important rule, elimination of feedback rule. That is following with the group discussion, we will discuss about the block diagram reduction technique in the pictorial form. Combining the blocks G1, G2 means multiplication G1 and G2. Parallel means G1 plus G2. Moving summing point ahead means that is G, that is right side. So moving summing point ahead of a block means that is 1 by G, that is equivalent diagram. Moving a big point that is behind the block means, behind means just divided by 1 by G. Moving a pick-off point ahead of the block means that is G, and again before this, that is G. Eliminating a feedback loop, that is G divided by 1 minus plus GH, and again 1 plus or minus G, because H is equal to 1. Swapping means that is plus minus, and AB means plus minus AB, that is swapping. And the example, you see the example, R of S is the input, and G1, G2, G3, G4, and H1, H2. So 4G block and 2H block, feedback block is 2. So first you apply the first rule, moving pick of point, that is pink round, look at the pink round, G4. Both G2, G3 is cascade, so you just multiply G2, G3, that is eliminating the loop 1. G4 plus G2, G3. Again, you just highlight this 2. That is moving picking point G4 plus G2, G3. And again, the moving pickoff point B behind the block G4 plus G2, G3. That is the third rule. And again, they eliminate the loop 3. You can get G4 plus G2, G3 divided by 1 plus H2 into that G block. That is G4 plus G2, G3. Remember G. Okay, the rule is G divided by 1 plus GH. So instead of G, we are using G4 plus G2, G3. Again, they're using rule 6, GH, that is G divided by 1 plus GH. Again, you can differentiate, that is reducing T of S. Transfer function is equal to Y of S divided by R of S. Another example, that's the same thing. We just eliminate the loop 1. Again, you can G2 divided by 1 plus G2 H2. Again, then not a feedback loop, moving pick off point A. Then eliminating the rule, that is eliminating loop 2, H3 plus H1 into at 1 plus G2 H2 divided by G2. Again, rule GH loop. So G divided by 1 plus GH. That is the formula. These are all the important rules we are using. That is the block diagram reduction technique. These are all the important topic. Definitely it comes for the final semester examinations. So we just remember the 7 rules, that's all. We can easily apply the 7 rules into the block diagram reduction techniques. Thank you.